Hello and welcome back. So this is all about factoring trinomials. So quadratic trinomials specifically. Quadratic because we're dealing with x squared here, and trinomials because we have three terms. So the first step that we have to do always is to locate what the a, b, and the c are. So the a in this case is 1, the b is 10, and the c is 21. So what you'll have noticed when you did the warm-up for this activity is that whenever we are factoring this into those two binomials, in the parentheses there where it's that double distributive, we are looking for something that adds to 10. So it adds to that b term, but multiplies to 21. So we're looking for it to spread this out into 4 terms, so then we can condense it into the 2 parentheses. So what we do to do this is the first step, and it gets easier over time. I'm going to write down all the steps here. So the first step is I'm going to write down 21. And I'm going to write down what numbers multiply to 21. Well, I always write down 1 and 21. All right, and then 3 and 7. That's it. All right, so now I have to ask myself, both of these sets of numbers multiplies to 21. Which one of these sets of numbers adds to 10? Obviously, it's 3 and 7. So what I do is I replace the middle term with 3 and 7. And what I mean by replace that middle term is I write it out as x squared plus 3x plus 7x plus 21. So that 10x becomes 3 and 7x. Now I can factor by grouping. Now again, I'm writing this out. It'll get easier over time. So the common term here, the GCF here is x, and I'm left with x plus 3. And the common term here is 7, so it's a positive 7, so I'm going to write plus 7, and then it's x plus 3. And then, if you remember, these two parentheses match, they come down into one parenthesis, and then these become the other. What you will notice is when I am factoring and a is 1, you can sometimes use the quick and easy method. We'll show you that pattern. These factors will turn into those numbers at the end of the parentheses, but only when a is 1. In the second example, again, I start off with locating what that A is, B is, and then C. And what I notice is A is 1. That's key in these examples. So I have to add to -4 and then multiply to -21. So the key is watching your signs. So I'm just going to take 21 again, and I'm going to write down our factors. And for this middle term to be negative, the bigger factor needs to be negative. So I can make those bigger terms negative. You can immediately see that if I add these two terms together, I get that negative for that b term. So some people are already at the point where they can jump right to the answer. They know that this answer is going to be x plus 3 and x minus 7. That's ultimately what the factored form of this quadratic is going to be. But to get there, what I'm going to do is I'm going to say x squared plus 3x minus 7x minus 21. I'm then going to group them in pairs, and I'm going to factor out that x. And I'm going to factor out that -7. And when I factor out a negative, remember it changes both of those signs. And you'll notice that I get the x plus 3 and I get the x minus 7 right there. The big thing with this is making sure that you watch your signs. So in this third example, you'll notice that again I have a is 1, b is negative 9, and that c is a positive 20. So one of the things that you'll notice as you get further in practicing these skills is that when the c, or this last term here, is positive and this is negative, it means that it's multiplying to a positive number, which means both the terms need to be negative. So again, it has to add to a negative number, but multiply to a positive number. The only things that do that are when you multiply two negative numbers. So again, I'm just going to write down my factors of 20. I always start off with 1 and 20, 2 and 10, 3 doesn't go in, 4 and 5. Now if I go past 4, I go past 5, so I can stop right there. I've written down all my factors. And if it's multiplying to a positive, both of these things need to be negative. Oh, so that's going to be my factors that I'm going to use. Again, those that can do it, when you're factoring, you can write it out almost automatically at this point, as that is my answer. But if you want to replace the middle term, group, factor out what's common, and because I factored out a negative, that becomes now a negative. And now these combine to one term, these combine to the other, and I'm all factored. So this next example, you'll notice when I write this down, a is 2, b is 4, c is negative 70. My a is not 1 anymore. So I can't really do my little trick where I can just look at the factors. Except that if you notice, 2, 4, and 70, I can divide them all by 2. So if I divide them all by 2, the equation now becomes x squared plus 2x minus 35. So if I put that 2 out in front, now my a is 1, my b is 2, and my c is negative 35. So I know now that it has to add to 2 and multiply to negative 35. By multiplying to a negative, I know 1 is positive and 1 is negative. And if it's a positive, I know that bigger factor, when I'm adding, has to be the positive one. So now I'm going to look at 35. And I'm going to say, well, 1 in 35, 2 doesn't go in, 3 doesn't go in, 4 doesn't go in, 5 goes in, 6 doesn't go in, and then once I hit 7, I'm back to those factors. So I'm done looking at that, and because this is a 2, I'm going to make the positive be the bigger number, so I'm going to make those negative. I can immediately see that these are going to be my factors that I'm going to use. Now, the trick with this question is I'm using this equation right here. So if you're really good at this point, you can just write the parentheses, so at the factored form, except when you write that, you got to remember put that 2 out in front, because we did kind of factor that out before we started. But if you still need this factoring by grouping, I will replace that middle term I will then group this middle stuff. So I get x and then x minus 5 and then 7 and then x minus 5. And now I have my factored form, and that is my answer. In this example, again, we're back to just some basic stuff, but sometimes quadratics can be a little bit tricky. So again, a is 1, b is 7, and c is 5. So I know they need to add to 7, and it needs to multiply to 5. So some people will notice this right away. But as I list the factors of 5, really it's only 1 and 5. I can't multiply anything else. It's a prime number. So if I add these together, they equal 6. So when this happens in this case, it's never going to add up to 7. Okay? Means it's not something that's going to be a nice, easy answer. Just like in mathematics, there's going to be tons of decimals. So this can't be factored whatsoever. We can use calculators to figure out what the answers are going to be, but we're not going to do that here. What we do say is, if in a case like this, and we're asked to factor something like this, we write this as a prime answer. So prime, just like 5 being a prime number, means that it can only be divided by 1 in itself. This is prime because we can't factor it. So we just write prime. In this last example, again, we have a quadratic, but it's a little bit of a tricky one. So what we are going to do is, again, we know a is 1 in this case, so that makes it a little bit easier for us. And this is constant, so that's the negative 36. So it doesn't appear that there's any b term. But in math, if something's not there, that means it's just really a 0, oftentimes. So we have a, b, and now c, so we know it needs to add up to 0, and it needs to multiply to negative 36. That negative means that one needs to be positive, one needs to be negative. So let's start writing down the factors of negative 36. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Oh, and 1 has to be negative, and that means the other one's positive, and it has to be, it has to be these two right here. So this only works when b is 0 if this is a minus in here. This is called the difference of squares, because x is squared, and 36 is really 6 squared, or 6 times 6. So you can immediately factor this into x plus 6 and x minus 6. Or, if you need to, write it out as x squared plus 6x minus 6x minus 36. Factor that by grouping. And now you have your answer. Now you know all the tricks of the trade for factoring when a is 1. There are different tricks for when a is not 1. So make sure you are labeling A, B, and C first. And now you can go defend the universe with this.